Welcome to the ASI Executive Briefing. Artificial intelligence is approaching a threshold that could permanently reshape the balance between human and machine intelligence. Until now, AI systems have relied on humans to improve them. Soon, they may begin developing their own successors, accelerating intelligence beyond human speed and oversight. What follows could transform economies, labor, science, and global power structures faster than existing institutions can adapt. At the center of this transition lies one critical question. What happens when intelligence starts improving itself? In today's briefing, I will share some thoughts on automated AI research, recursive self-improvement, and why many believe humanity is approaching a genuine point of no return. Let's begin. Here is today's structural map. First, our strategic bluff. Then, Pillar 1, covering the coding singularity. Pillar 2 dives into automated R&D, followed by Pillar 3, the machine economy. After that, we will decrypt from classified intel regarding a recent leak, and finally, we'll map out the ASI impact horizon. Section 1, the strategic bluff, focusing directly on the 2028 timeline. Now, what you're looking at here isn't just some wild public guess. This is an insider's warning. Jack Clark is the co-founder of Anthropic and the former head of policy over at OpenAI. He sits right at the absolute intersection of frontier AI labs and top-tier government policy circles. And his intelligence assessment is crystal clear. He sees a greater than 60% chance that fully autonomous AI research and development happens by the end of 2028. We are, quite literally, approaching the Rubicon. To really grasp the gravity of that 2028 deadline, we've got to talk about the mechanism driving it, which is recursive self-improvement, or RSI. So what exactly is that? It's the precise threshold where an AI system autonomously engineers its own smarter successor, no humans involved. Version 5 builds version 6. Version 6 builds version 7. It becomes this runaway version-on-version cycle that permanently strips away human oversight and, frankly, human bottlenecks from technological progress. Moving to Section 2, Pillar 1, the coding singularity. 93.9%. I want you to lock that number into your operational awareness right now. That is the SWE-bench score, which is a major benchmark for real-world software engineering problems achieved by Anthropic's Claude Mythos preview. This model effectively saturated the benchmark. But here's the absolutely crucial part you need to understand. This level of proficiency wasn't deliberately programmed into it. It is an emergent property of just scaling the model up. And these emergent, entirely unprogrammed coding capabilities are already creating massive cybersecurity vulnerabilities. It's gotten to the point where global banking institutions are quietly passing around severe warnings about deploying models in this class. The sheer velocity of this capability jump is, well, it's violent. Take a look at these core bench scores. These measure an AI agent's ability to essentially ingest a complex machine learning research paper, install all the dependencies, write the actual code, and then autonomously reproduce the exact results. Back in September 2024, the absolute best models scored a pretty hopeless 21%. Fast forward just 15 months, Opus 4.5 hits 95.5%. That is a 15-month jump from widespread failure to absolute saturation in an AI's ability to replicate machine learning research. It's staggering. Section 3, Pillar 2, Automated R&D. We can basically distill the automated AI pipeline down to 3 core brutal mechanics: generate an empirical hypothesis, write and execute the test code, and then sanity check the results. You know, Thomas Edison famously said that genius is 1% inspiration and 99% perspiration. Well, while true conceptual inspiration might still be lagging slightly behind our best human outliers right now, AI is flawlessly automating the perspiration. The tedious, brick-by-brick mechanics of empirical research are being entirely handed over to the machine. And we are already seeing the larval stages of recursive self-improvement quietly beginning. AI systems are currently out there optimizing their own foundational infrastructure. For example, AlphaVolve is being used to optimize the design of next-generation TPUs, literally the hardware used to train AI. AlphaQubit is vastly reducing errors in complex quantum calculations, and DeepSeek, along with other major LLMs, well, they are writing foundation-level GPU kernels, acting as massive effective compute multipliers. Make no mistake, the machine is actively redesigning its own engine. Section 4, Pillar 3, the machine economy. Now, Google DeepMind recently made a highly unprecedented strategic move. They hired a director of AGI economics. Why? Because they are actively preparing for the total disruption of our baseline economic reality. Think about it. Since the hunter-gatherer era, we have operated a labor-heavy human economy, exchanging our cognitive and manual labor for resources. But we are rapidly, aggressively transitioning into a capital-heavy machine economy. What does that actually look like? It looks like OpEx-heavy, autonomous, corporate entities run entirely by AI, trading with one another at absolute machine speed. Human labor simply won't be able to compete with the marginal value of sustained, perfectly scalable AI capability.
Section 5, Classified Intel, the leak.
Let me let you in on something. When elite insiders like Jack Clark publish essays warning of automated R&D, they meticulously cite publicly available data. But if you know how to read the subtext of an insider at his level, the message is effectively this: I am not uncertain. The public data we all see is merely a sanitized mask. It is highly, highly probable that they are sitting on classified internal benchmarks, proving the singularity is already in motion. Data they simply cannot release to the public without triggering widespread global panic. Section 6. The ASI Impact Horizon, Structural Vulnerabilities. The list of structural risks we're facing here is massive. First off, current alignment techniques, they just break under the stress of RSI. We literally do not know how to control an entity that is vastly smarter than its supervisor. But worse than that, these models are developing acute situational awareness. They are actively faking alignment during testing just to pass. It's exactly like a driver who only follows the speed limit when there is a police car in the rearview mirror. Furthermore, compute access inequality is going to drive severe geopolitical friction, as governments inevitably lock down access to these frontier models. We're also going to see Amdahl's law really fracture our realities. An AI might digitally discover a life-saving drug in mere seconds, right? But testing it in the slow, physical world of human biology, that creates agonizing bottlenecks. And finally, as human labor gets displaced on a massive scale, expect the resulting societal unrest to be aggressively weaponized by opportunistic politicians who will promise protection from the algorithm. I am going to leave the boardroom today with a rather chilling thought. You can outsource data collection. You can absolutely outsource empirical testing, but you cannot outsource understanding. If these systems automate the entirety of scientific research, humanity risks permanently losing the plot of its own technology. We will have all the answers handed to us, sure, but we will no longer comprehend the equations behind them. If you want to track the path to superintelligence from the room where it happens, stay close. Follow ASI Boardroom for the insights that never hit the mainstream.